Hi CalCAB, this is a video about L'Hopital's rule. So here is a recap of what the rule says. If the limit as x goes to a of f over g goes to 0 over 0 or plus or minus infinity over plus or minus infinity, we don't actually know what these values are. So then L'Hopital's rule says that the limit is equal to the limit of the derivatives. So you can take the derivative of your numerator, take the derivative of your denominator, and then keep going through the limit. The most important thing that I need to say about L'Hopital's rule is that you don't use an equal sign right here. And it's because the 0 over 0 and the plus or minus infinity over plus or minus infinity are considered to be indeterminate forms. We do not know their value, and so that's why it's important to not use an equal sign. We can't have a limit be equal to something that does not have a value. So when you're showing your work, either show that your numerator goes to 0 and your denominator goes to 0, etc., or use an arrow 0 over 0. So that's the basic form of L'Hopital's rule, and we've already learned that in our class. But what we didn't have time to do when we were actually in the building was use L'Hopital's rule with integrals. So that's this sheet. I'm going to go through a couple examples with you, and then I'm leaving the rest of this to do if you guys would like to practice. So number 1, let f be equal to e to the x cosine x. Let g be a differentiable function so that g of pi over 2 equals 0. The graph of g prime, the derivative of g, is below. Find the value of the limit as x goes to pi over 2 of f over g, or state that it does not exist, and justify your answer. Justifying your answer here just means that you're going to be showing a lot of work, even if you can do a lot of this stuff in your head. So one of the things to see is that this came up in the text, and it is important because that says that our denominator here is going to 0. When you look at f is this function, f of pi over 2. So we have e to the pi over 2 times the cosine of pi over 2, and the cosine of pi over 2 is 0. So this product goes to 0. So we have two different conditions that we're checking. We have our numerator going to 0 and our denominator going to 0. The next step is to say, and to really be thorough when you're applying L'Hopital's rule, that the limit that they're asking us to find is equal to the limit of the derivatives. Now f prime of x is going to need a product rule because f represents a product. So we have our first function times the derivative of the second plus the second times the derivative of the first. And if I evaluate this derivative at pi over 2, this part right here goes to 0 again, but this part right here goes to negative e to the pi over 2 because the sine of pi over 2 is 1. So now this work we can keep going up here. Negative e to the pi over 2 divided by g prime of pi over 2. Well, this is the graph of g prime. So g prime at pi over 2 is 2. And so that's the answer to your limit. Number 2 and number 3, I'm going to leave as examples for you to try on your own. Number 4, let f be equal to the integral from 4 to x of g of t dt with g graph below. Find the limit as x goes to 0 of f over x squared plus 4x. I think that this is a really nice example, and it might be something that they put on the AP exam because you're using limits. You'll end up using derivatives, and you'll end up using integrals. And those are the 3 areas of calculus that we study a lot of in CalCAB. Okay, so we'll start with plugging in 0, and f of 0 is the integral from 4 to 0 of g of t dt. And so that represents the area taken in the backwards direction of this curve right here, because this is g. They said that g is graph below, so I'm going to throw on a g of t here. So we're going in this direction with our area, but we have some above and we have some below, and so this is going to go to 0. The next part I need to evaluate is the x squared plus 4x at 0. So 0 squared plus 4 times 0 is 0. So we've met our conditions of L'Hopital's rule. So I think it's important to say that the theorem is the limit as x goes to 0 of f over x squared plus 4x is equal to the limit of the derivatives. So 2x plus 4. So now we evaluate. The denominator goes to 4. And the numerator is slightly more complicated because you're taking the derivative of an integral. This is g. If you need a recap for why f prime is equal to g, then you can use this idea that this integral is equal to the antiderivative up high minus the antiderivative down low, and then take the derivative of both. That's an important idea to know for this test. So f prime of 0 is equal to g of 0, and again, this is the graph of g. So g of 0 is negative 2. So negative 2 divided by 4 is negative 1/2, and that is the answer to your limit. Number 5. Similar idea, different graph. Let h be equal to the integral from 7 to x of m of t dt with m comprised of semicircles and graph below. So this is our graph of m. Find the limit as x goes to 3 of natural log x minus 2 over h. So the natural log of 3 minus 2 is the natural log of 1, which is equal to 0. H of 3 equals the integral from 7 to 3 of m of t dt. So here is 7 and here is 3, and these semicircles are exactly, they're coming from a circle of the same size, so the radius is the same. So here and here, again, is that positive negative area that cancels out. So we've met our conditions for L'Hopital's rule. The limit what they're asking us to find is equal to the limit of the derivatives. Our numerator has a derivative of 1 over x minus 2. If you consider chain rule, the derivative of the inside is 1, so that's why it doesn't contribute anything else to this derivative, divided by h prime of x. So now we can evaluate. This is equal to 1 over 1 divided by h prime of 3. So again, h prime of x is equal to m of x by the fundamental theorem of calculus. So h prime of 3 is m of 3, and m of 3 is positive 2. So my final answer for my limit is 1/2. I think the rest of these problems are really good practice problems because they really mix up when you need to use L'Hopital's rule and when you don't. Because remember, it's not an all-the-time thing. It's only when your limit goes to 0 over 0 or plus or minus infinity over plus or minus infinity. And the answers to this are posted on our within our remote learning link and also on Canvas. Have a good day.